Then 14 is using that same limit definition. The limit as h goes to 0 of f of x plus a little bit minus f at x over h. But in this case, x, or the place we want to take the derivative at, in this case, I guess that's a. In this case, for number 14, a is equal to 0, and f of x is equal to 1 minus x squared. So here it's going to be 0 and 0, right? So lucky for us, 0 plus h is just the same as h. That's not going to happen very often, so we're going to take advantage of it. And so we're going to find f at h, and that's going to be this. And then we're going to find f at 0, and that's just going to be 1 minus 0 squared is 1. So when I go in here, it's going to be 1 minus h squared, all that crap minus 1 over h. The 1's cancel out, and you get negative h minus h squared over h. So it's a limit we can do. We plug in and we get 0, 0, so we know that we have a hole that we must remove. So in this case, I remove the h over h, and I'm left on the bottom with a 1, on the top with a negative 1 minus h, right? So since that equals 1, you're left with, limit as h goes to 0 of negative 1 minus h. As h goes to 0, you just get negative 1. So let me go back here. I'm going to just say 12a, 14a, 16a, and then we'll do 18. I'll find the equation of the tangent line. Okay, so we're just going to do the a part on 12, which is to find the slope of the tangent line. So the slope of the tangent line we found here was 1/5. If we go back here, the slope of the tangent line at x is equal to 0 we found was negative 1. So we're just doing 14a. Now we're going to do 16a. So for 16a, in this case, the function is root x plus 8, and we're at a is equal to 1. So it's this equation. So there's the square root of x plus 8. I'm trying to find at 1, what is the slope of this tangent line, the line that hits it at exactly 1 point. Let's go find that slope. So it's going to be the limit as h goes to 0 of f of 1 plus a little bit minus f of 1 over that little bit. So we're going to go from 1 to 1 plus a little bit. We're going to find that secant line slope and then let that h slide to 0. So first we're going to take f of 1 plus h, and that's going to just be putting in 1 plus h into our function. So you get the square root of 9 plus h. And then we're going to put in 1, and you're going to get the square root of 1 plus 8, which is square root of 9, or 3. Notice it is not plus or minus because we're not solving an equation. We're evaluating the function square root, so we only get 3. So that means up here, 1 plus h turns out to be square root of 9 plus h, and then f of 1 turns out to be 3 all over h. So what we really have is, and I don't have to write it again, I have the limit of square root 9 plus h minus 3 all over h. So that should look similar to problems that we have seen before. We've already done those limits, and the reason we did is they help us do these sorts of problems. So I'm going to multiply on top and bottom. I know if I plug in, I'm going to get 0 over 0, so there's a hole I have to remove. And we do that by using the conjugate. Root 9 plus h plus 3, root 9 plus h plus 3. In this case, it's going to give me the first one squared, which is 9 plus h, minus the second one squared, which is 9, all over h times root 9 plus h plus 3. Why is that amazing? Because on top, the 9's cancel out. I'm left with h over h root 9 plus h plus 3. Why is that great? Because you can factor out that h over h, and you're left with 1 root 9 plus h plus 3, right? So that's just equal to 1. And if you'll allow me to, I'm going to move that up here. I'm going to delete that. Just say, look, that's what I'm doing. Boop, boop, that's what I'm doing. So here, that's the limit as h goes to 0 of 1 over root 9 plus h plus 3. Well, as h goes to 0, you get root 9 plus 3, which is 1/6. So the slope of the tangent line is 1/6. So that's 16a. So now let's do 18, and we're going to do it full out. So the 8 part just wants us to find the slope of the tangent line. Then we'll find the equation of that tangent line. So 18 is f of x is equal to negative 3x minus 1. A is equal to 4. So I'm going to find the limit as h goes to 0 of f at 4 plus a little bit minus f at 4 all over that little bit. So over here on my scratch paper, I do f of 4 plus a little bit. What that's telling you is that you put in 4 plus a little bit in for x, so you get negative 3 over 3 plus h. But then f at 4 is negative 3 over 4 minus 1, so it's negative 3 over 3, which is negative 1. So this is really the limit as h goes to 0 of, well, this I can just replace with this, and this I can just replace with that. So we get negative 3 over 3 plus h minus a negative 1, which just turns out to be plus 1, right? Because that's minus a negative equals a plus. And so it's all over h. So then to get rid of this 3 plus h, I multiply it on top and bottom by 3 plus h. So it hits the first one and gives me negative 3, hits the next one and gives me 3 plus h. So if I distribute this to here, the 3 plus h's cancel. If I distribute it to here, I just get 3 plus h. Then the denominator is h, 3 plus h. How do we know we are on the right track? Because these cancel, and you just get h over h, 3 plus h. That's great because you can factor out that h over h. You're left with 1 over 3 plus h. That's not equals, that's times. That's just equal to 1. And so it's really the limit as h goes to 0 of 1 over 3 plus h. But as h slides to 0, you just get 1/3. So that means that the slope of the tangent line is equal to 1/3. So if I come over here and I do 18 part B, then I want the equation of a line, and the equation of a line is y minus y1 is equal to m x minus x1. And we found out that at the point x equals 4, we know that the slope is 1/3, but we also know that f of 4, over here we found out that f of 4 was equal to negative 1. It's equal to negative 1, so I can put in my y1, and it's y minus a negative 1, so it'll be a plus 1. It's equal to this. So really there's nothing much to do except plug in values that you've already used. The x that we used to find out where the slope of the tangent line was, and then also that associated y value. So that's 18. Now we're doing 22.